Hi everybody, today we're going to talk about powers and roots of numbers. When we multiply a number by itself multiple times, it is helpful to rewrite the expression. Here I have s times s times s times s times s, which is hard to kind of comprehend in our head, but if we count that we have 1, 2, 3, 4, 5 s's, we can write that as s to the fifth, which I have to be careful because my s's and 5s sometimes look alike. But what we see here is that I have a power 5, which tells me how many times I multiplied s by itself. The notation a to the n represents multiplying a times a times a times ... a, where they are in factors of a. Here we call a the base, and we call n the exponent of our expression. Let's try rewriting s times s times s times s times s times t times t times w times w times w times w. So what we see here are we have s's, we have t's, and we have w's. So the s is the same as we had before. We had s to the power 5. T I have twice, so I would call that to the power 2. And then w, I have 1, 2, 3, 4, so that's to the power 4. So we want to pay attention to how many times a particular factor is multiplied by itself, and that becomes the exponent of the base. Let's take that and use some numbers. Here I have 18 times 18 times 18 times 18 times 18. So 1, 2, 3, 4, 5, 6 of them. I'm going to write that as 18 to the power 6. Eventually we'll get to the calculator and we'll evaluate the number, but for now I just want to rewrite it. Let's talk about some common exponents that you're going to come across. The first one is x to the power 1. An exponent of power 1 is usually not written, so if you have something like, say I had 5, we can assume this is 5 to the power 1, or if I had 3 all by itself, that is 3 to the power 1, so the exponent is understood when it's a power 1. When we have x to the power 2, we call this squared. So anything power 2, we're going to say like 3 squared, 4 squared, 5 squared, makes it easy for us to say. Same thing with power 3, we call this cubed. Let's look at how we can put this in our calculators. So I'm going to pull a couple calculators to show you, so I make sure you get different views of what they can look like. Here's a standard calculator downloaded for my computer, and you see there's a power 2, so I can hit 8, and then if I hit power 2, it evaluates it as 64. Notice it says square of 8, so it's telling me that it squared the number. Same thing, let's pick 9 and square it, I see 81. Let's look at a different calculator. This is a TI-84 graphing calculator. I just want to show you it looks a little bit different. So here is 8. Over here I have squared. That does my exponent. I evaluate it. Let's do 9. I hit squared. I evaluate it. So it goes up. If you watched my videos before, you know that I really love Desmos, and it's something I use a lot. You can type Desmos in Google, your search engine, and it should come up to the graphing calculator or one of the calculators, but I want to show you in here how I would do that too. So I hit 8. I can hit shift and 6, which does an up arrow, and then I could put in 2 and it's going to square it. I could also go back to 8, and there is a keyboard that I can open. The keyboard contains power, so here you can see power 2. Let's do 9. Also show you I could hit this A to the B, which just says go up, and then you can pick the power as well. So you're not having to memorize these powers. A lot of times they are going to get really big, so I want you to use your resources and make it easy. Let's do a few where we identify the base and the exponent, and then we'll simplify. So with 4 cubed, the base is 4. The exponent is 3, and if you put this in your calculator, 4 cubed is equal to 64. B says negative 6 squared, so my base is negative 6. The exponent is equal to 2, and then I'm going to show you this. This is negative 6 times negative 6 is a positive 36. When you get to negatives, it's really important that you put these in exactly as they appear, how they're written down. So see how I had parentheses negative 6 squared, so I want to make sure you see those parentheses. I'll show you that in the calculator as well. This last one says negative 5 to the 4. This time the base is 5. It is not negative 5. There's that difference between parentheses and not parentheses. So what this expression says is you multiply 5 by itself 4 times, and then whatever you get, make it negative. So pay attention to that really closely. It is kind of tricky, so you want to make sure parentheses versus not parentheses makes a difference on the base. The exponent will be equal to 4. And then if I put this in my calculator, I get negative 5 to the 4th is negative 625. Let me show you this in a calculator. I'm going to pull up the TI because I think it's going to do the best job. So I'm going to put parentheses. I do -6, close parentheses, and I square it. There's 36. Let's do -5, and then I need to do a power, so see how I have this button that goes up to a power. Let's hit power 4, and see it gives me -625. So super important that you pay attention to that little negative, makes a big difference. Let's do a few that are bigger. I'm not going to go back to the calculator this time, but I would encourage you to try these as you're watching the video to make sure you understand how they work. So 7 to the power 5 is 16,807. -9 cubed is -729. And then 2 to the 7th is 128. Don't try to do these in your head or by hand. You want to grab a calculator to do exponents. So the next thing we need to talk about is roots, which are also called radicals. And basically a root is the opposite of an exponent. So how I would read this is the square root of 11 squared is 11. See how that square and the square root cancel out? Or the cube root of x cubed is equal to 7. The cube root and the cube cancel. So this idea is radicals reverse exponents. If I have x to the n is y, that means the nth root of y is x. Don't let that confuse you. What that says is the nth root of y, but y was really equal to x to the n. It feels like these two cancel and I'm back to x. You can think of the nth root of y as looking for what number times itself n times is equal to y. So let me show you a few examples that'll maybe clear this up a little. If I had the square root of 64, I think 64 is 8 times 8. So I had 2 8s, so that's exactly what I want. So it says the square root of 8 times 8 is just 8. If I have the fifth root of 32, well, I could rewrite 32 as 2 times 2 times 2 times 2 times 2. And so what number times itself 5 times is equal to 32? That would be 2. The last one I have here is the fourth root of 8 to the fourth. So what number times itself 4 times is 8 to the fourth? That would just be 8. When you're looking at this, n is called the index. The number under the radical sign is called the radicand. You're going to find that we don't write the 2 when we're looking for the square root of 2, but we would say the index is 2 even though you don't see it in the problem. So when you see the square root of x, I want you to think there is an index of 2 in the radical. I also want you to know that the answer is positive when you take the square root. I am just going to talk about square roots on our next couple of problems because that is what we deal with in this course. So yes, there are other kind of radicals and roots, but I just want to focus on what we really need for this class. So let's simplify these. So feel free to grab your calculator. I'll make sure I show you how that works also. So the square root of 81 would be 9. The square root of 4,900. Well, let's try that. Just so I've shown you a couple of things, let's grab the scientific calculator on my computer. Here you can see the square root, so I'm going to put in 4,900, and then I hit the square root, and it tells me it's 70. Let's compare that to a TI-84, so same kind of thing, but in this one, I first put in the square root, so it is up here over the x squared, so I hit the square root, I put 4,900. When you hit enter, it says 70. Let's make sure we hit them all, so let's try Desmos also. Here you can see if the menu opened, I hit the square root, I put in 4,900. So what's important is that you know for your calculator, do you first put in the number or do you first put in the radical? There is this choice that's kind of nice with Desmos that I can type SQRT. It's a shortcut that turns into a square root, and then I can put the 4,900 there too. I kind of like sometimes to be able to type it versus hitting the keys. So let's try one more. Again, encouraging you to try it in your calculator as we go along. Try the square root of 289 and you should get 17. So I'm just going to finish up with doing a couple of examples that have more than one operation. So A, I have the square root of 3 times 15 over 5. What we want to do is do the radical last. So maybe we do 3 times 15 is 45 over 5. Let's simplify that fraction. So 45 over 5 would give me 9. Square root of 9 would be equal to 3. Same thing for the last one. I have the square root of 18 times 6 over 3. So let's start with 18 times 6 is 108. Then we'll do 108 divided by 3, which gives me 36. Square root of 36 is 6. Not all radicals come out so nicely. This is our beginning. As we go in the course, we will have some that have decimals, and that's okay too. We'll continue to talk about radicals, but this is a good introduction to get us started with the notation and how to use exponents and radicals.